You probably recognize the music and the title. Thank you very much. The whole point of the abstract, if you read it, was a wordplay on songs by Daft Punk. I didn't actually say too much about the topic. I just wanted to entice people, see how many people would turn up. Okay, so, guys, finally on. Before I actually begin, unless it's gonna work. Let's go with that one. What's going on? See, the reason is you never use PowerPoint for presentations. Use something else. Okay, there we go. Daft Punk, rocking Gradle. So before I actually begin, let's see. I said something on the abstract related to Maven and Gradle. So how many of you actually make use of Maven today for building projects? Okay, so a bit more than half. How many use Gradle already? A few hands. And, sorry for you guys. Something else, make? So this is just Java. I assume most of you are Java developers? Okay, good. Right. So I promise this is the only boring slide I have for you. This is me. I come from Mexico. This is why I wear this little flag on my shirt. Again, just for the recording, I think that now is better. And but I currently living in Switzerland with my wife. We work on a company called Canoe, and we travel around the world talking about the technologies that we like and the technologies that we use in order to let developers know what is out there. And if it's good enough, then we encourage you to try it out. This is definitely will not force you to try them out. It's just that if you see that it's good for you, try it. If the tool is not right for you, or it's not right for your project, then use another one. I'm also a member of the Groovy development team, so I love Groovy, but I also love Java, so I'm really glad that you're here. So for those that do not know what Gradle is, and by the way, I will have some light coding here, so don't be afraid, there's going to be code. You please feel free to ask questions at any time, and there are no silly questions. That is my motto. You have some question that is burning in your mind, please ask it right away. I'll do my best to answer it. Come, please. Okay, so Gradle is a build tool that is designed to take advantage of conventions. So when I ask you about who uses Ant, Maven, and Gradle, if we go back a little bit on the history of the build tools in the JVM, at first we didn't have anything, and it was kind of a pain to build our projects. Believe me, if you think you're having pain with Maven, it was much more painful before. And then came Ant. Ant gave us the ability to build Java projects in many different platforms. The problem is you have to use XML, but it gave you a lot of power. So if you needed to do something, you create a task, wrap it with an XML DSL, boom, you were able to use it. Then came the next project, and what would you do? You copy and paste from a previous script, try to adapt it to the new project, battle the build for a couple of days, eventually put into submission, or you just agree that, yeah, the build script has some words. We will just ignore this failure, we'll ignore this thing, and we'll move on, right? We continue to drag that baggage to the next project. Then came Maven. Anyone here use Maven 1? See, almost nobody remembers Maven 1. Most people know about Maven 2 or Maven 3. So Maven 1 was most like Ant, so it gave you a lot of things, a lot of freedom. You still had to build with XML. It actually had an XML DSL where you could create loops and if-else, conditionals. It was a full programming language with XML. Just imagine that. Do you really want to program with XML, real programming with XML? Well, that was Maven 1. And as silly as it sounds, I really like Maven 1. Not just because you had to use XML, but because it gave you a full programming language behind it. Whereas with Ant, you only have a DSL. Now, it was kind of a pain to use XML to program, so people decided to create a Maven 2, where you create your plugins with Java, again back having used a DSL in the form of XML. Kind of work. And it gave us conventions. So now it was much easier for you to transform or translate a build script from one project to the next one, as long as you made use of those conventions. If you did not, you still can configure some of this stuff, but you know that the moment that you strive away from the happy path in Maven, things get ugly. No matter how much you can configure this thing, it can get really ugly. So this is where Gradle comes in. It takes on these ideas of configuration and convention, but it also gives you the power to configure everything. If you cannot do it, believe me, you can have access to this Groovy-based DSL, and you can create everything you need. So in other words, what Gradle provides you is the ability for your project to be the leader and not the build tool. In the case of Maven, it was said yesterday by Dr. Venkatur Ramanian, if you thought that you used Maven, you were wrong. Maven is the one that uses you. It's kind of like a paradigm shift. So the great things about Maven, Gradle actually, you don't have to throw away your knowledge that you already have for Maven. If you follow the Maven conventions, then your project can make use of those conventions if you use Gradle. It is very expressive. It has a DSL. So instead of an XML DSL, it uses a Groovy DSL. People that do not like dynamic languages may think twice on using Gradle just because the first thing that they see is the Groovy DSL. Turns out that most of the Gradle project, most of the Gradle code base is written in Java. So what you see on top is just a nice Groovy DSL. You could, or somebody else could write a different kind of DSL on top of the Java-based API. So far, nobody has ventured to do this just because the Groovy DSL is good enough for the time being. It's really extensible. It has a really thriving plugin community. And I'll have something to say about that in a moment, in a couple of slides. It also fosters fast and reproducible builds. This, I would say, is one of the key aspects of Gradle. You can fix the Gradle build, the Gradle version number for a particular project. You can also fix the version for all the plugins and all your dependencies much better than in Maven, so that you can assert that if you build your project today with these versions, when you come back 6 months later or 1 year later, for some auditing purposes, somebody asks you, you have to provide, again, the same artifacts that you built a year ago, guess what? You will be able to do so. Certainly, it will be kind of impossible, not certainly impossible, very difficult to do so with Maven. And it's also CI friendly, which means that you can create and build projects inside a continuous integration environment. Usually, it's most likely you use, I don't know, Jenkins, Hudson, TeamCity, Bamboo. There are many CI servers out there. If you're building with Maven, you have to talk to your IT infrastructure so that they push the right Maven version for your project, isn't it? And it's not that it's 5 minutes and you're done. You have to file an enhancement request, and then the IT has to go, and the motions and bureaucracy. 4 weeks later, you got Maven, it's probably the wrong version, and you have to go to the motions again. With Gradle, you just put the Gradle wrapper. 5 minutes later, you're building your project with the right versions, and you don't have to bother IT with this because it's something that goes along with your project. This is such a nice feature that the Maven people are copying for Maven 4. Okay, so the reasons why, I already gave you some. So this nice company in Estonia called Zero Turnaround, that they make us of the JRebel library. They also have this initiative called Rebel Labs, where they query developers and they output technology reports every so often. Now, they made this one at the end of 2003 or the beginning of 2004, where they query developers about the different UI or build tools that they make use of. The big three winners were, not surprisingly, Maven, Gradle, and End. So you see how much, in the case of Maven, how much it has grown in the past years. Again, this is the data until 2013. If we were to query developers right now, believe me, the numbers for Gradle will be much higher. So Maven was pretty much the dominant build tool. Everybody knows Maven. It has good support in the IDEs, all major IDEs, and is easy to get into. But as you see, the numbers of Gradle, it was started quite small, and in 2012 they make the final push for the big 1.0, and that is when you see the numbers rising incredibly. And then you see Ant with the combination of Ivy, because Ant does not provide dependency management like Maven and Gradle. And Ant is going down. So if you still rely on Ant, and specifically Ivy, I have bad news for you. Ivy is a dead project. Nobody is maintaining this project anymore. It has plenty of bugs. So at the very least, if you cannot migrate to Gradle, switch to Maven as soon as possible. Now they also ask about the different aspects of these tools. So the first one says the learning curve. Learning Maven is quite straightforward. You can use the IDE certainly to write most of the XML. Just put some standard definitions at first. Where are your dependencies? Maybe this dependency management, maybe it's a multi-project. You put the build dependencies, you put the build configuration, maybe you define some repositories. That's it. The rest of it is configuring plugins or finding the right plugin to be used if it doesn't exist. And in the case of Gradle, the learning curve is a little bit higher. Why? Because people that are new to Gradle have to learn also the Groovy DSL. Now, I've been using Groovy for a long time, since 2006. So for me, learning Groovy, I don't see much of a problem. But for people that are used to Java, let me tell you, Groovy is as easy to learn as Java. As a matter of fact, it's close to 95% of the Java syntax that you use today can be used with Groovy. So if you rename your Java class into .groovy and compile it with the Groovy code, it's most likely that it's going to succeed. And if it fails, the Groovy compiler is very friendly in terms of error messages. When something fails in Java, you get error, symbol not found, line number something, and then you have to figure out why. In the case of Groovy, we'll tell you, you know what, this method does not exist. You probably want to call this one or this other one. So it gives you more information. So in this case, it's definitely friendlier. Complexity. Maven is very trivial. Again, XML, boom, you're done. There's not much complexity here. Gradle is a bit more complexity. Why? Again, the Groovy DSL, and it has a much richer project object model. This is another reason why Gradle came to be. The object model that you find in Ant, there is no object model. The object model that you find in Maven, it's better, but it's very strict, it's very rigid. And the object model that you find in Gradle is very flexible. You can create much more things than what you could do with the other ones. In case of plugins, Maven has the lead because it has much more time to mature. So there are much more plugins, but Gradle is quickly picking up the pace. And in Ant, well, you can find Ant tasks for pretty much everything. Community and documentation. The Maven community, I will say it is good. It's good enough. Sometimes you'll find that people are very fun on their ways, and if you tell them that this plugin and this other plugin do not work well together, and there should be a better way to work together, they're most likely going to say you're not following the Maven way. So there's kind of a bit of a drawback, I would say. And documentation, sadly, is not as good as it could be. In the case of Gradle, this is the most outstanding point. Documentation is really good, and the people behind the Gradle project are always continuously looking at how to make it better. And, well, it's not good kicking on the dead horse anymore. Developing tool integration. Again, Maven has a lead here because of the long time. So Maven integration with the popular IDE tools, outstanding, really good. It doesn't matter which one you use. In the case of Gradle, I will say, how many of you use IntelliJ? Just a few hands. IntelliJ has the best support so far in Gradle. I guess most of you use Eclipse, right? No worries. Gradleware, the company behind Gradle, has pushed for creating a plugin called BuildShip, and they're going to make Gradle development inside the Eclipse platform a much better experience. So if it's not today, it's going to be in a couple of months. So don't worry, it's going to be there. So I mentioned already this company called Gradleware. There is a company behind the project. The project Gradle is open source, is always going to be open source. It's licensed under Apache 2, same license as Maven. As a matter of fact, Sonatype is the company behind Maven. So it's kind of the same thing. This company, Gradleware, posts this, the list of the different customers that they have. These are paying customers. Of course, you could become a paying customer if you want, or as we do, just continue using the open source version. The forum support that they have is pretty good. And they don't list it here, but they also have Apple now. So if they are able to list Apple as a customer, just imagine how great things are for them. A few more other things that we have in Gradle, and I promise that we're going to switch into code. The caching of input and output. This is something that really annoys me from Maven. Say that you have configured your tests and your reports, and what you want to do now today is you clone your repository from start, and you want to build the site. What happens? Well, your code gets compiled. If you have any processors, pre or post processors, they get run. Then you run the tests. If you happen to have Cobertura enabled, what happens? Your tests get run twice. Annoying thing number 2. Then generates all the reports, the Java doc, and finally you get the site. You missed something in your documentation, so you change the document, only the document, and then generate the site. What happens now? The code gets compiled again, the test gets run again, Cobertura runs the test twice, documentation gets run, and finally you get the site. See, you didn't change the source code, still you had to go through all the tasks one again and again and again. So Gradle knows this, and knows that it's annoying, so it can cache inputs and outputs. So if the inputs, once you run a task, did not change, and it already has the outputs, well, guess what? The task is not run, so it continues with the next one. So it makes that when you're compiling code and you're generating tests and all these things, if you do not need to compile your code, you only change your test, well, only the test gets compiled and get executed. If you generate documentation and it did not relate it to compiled code, guess what? Those code sources get not compiled, the tests get not run, only the documentation gets updated. That's much better. It has a much richer and configurable lifecycle. Maven, we do have a lifecycle. There's a pre-processed classes, compiled classes, pre-processed resources, post-processed resources, blah, 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 blah. It's like 20 phases or so. You cannot add phases. You cannot change the phase order. It is very, very strict. It's fixed. Whereas with Gradle, no worries. You can change everything around as long as it suits your project. And remember, it is the build tool, the one that bends to the project's will, not the other way around. It also has the Gradle daemon. Now, when it doesn't matter what it is Maven or Ant or Gradle, when you kickstart a build, you have to run this thing inside a JVM, which means somebody has to boot up JVM and then run build. If you continue to do this over and over and over and again, you will keep paying the price of bootstrapping a JVM every single time. So what the daemon does is run a JVM in the background, and the Gradle command is actually a client command. So the first time you kickstart the JVM, and the next time you run the Gradle build, it actually uses the JVM in the background, so it's much, much faster. It's already a warm JVM. We also talked a little bit about the Gradle wrapper before. This is a set of scripts in a tiny jar that if you tell it which Gradle version you want to use, and if it's not already available in your project, it will download Gradle, use that version and continue, so that the next time that you want to compile, if you use the wrapper, it knows that you already have the version and continues. This is the reason why it works on a CI environment, because the wrapper is able to bootstrap Gradle itself. Multi-project builds. Who likes to work with multi-project builds and the reactor project with Maven? But really love. So not that you have to, but really work with the reactor project. It's only a few hands. And it's good that we are able to use multi-project builds, but it are really a pain in Maven. I'm going to show you how easy it is to do with this thing with Gradle. Plugin development is definitely much more intuitive. Multiple builds. So you have a root project that has sibling projects, and all of them have to be built in the same build step. So, plugin development. How many of you have created a Maven plugin? Did you like the experience? Not that much. That's what I fear. I also have created a few Maven plugins, and I hope it doesn't come that I have to build another one. But in the case of Gradle, I have built close to 20 or so, and I really like the experience. It's much easier, not just to build them, but test them, and then apply them to your projects. Finally, again, the better documentation overall. How to do things the Gradle way is much easier than doing things the Maven way. So, how can you get started with Gradle? Enough of the theory. Let's see some practice. Okay, it's easy. Gradle, you install it pretty much in the same way as in Maven. You download a zip file, configure your path environment, then you're done. Then comes the next release of Gradle or Maven. What do? Download the zip file, configure the path, you're done, right? It starts to get tiresome. So I got good news for you. There is another tiny project called GVM. You go to gvmtool.net. The easiest way to install it is using this command line. If you got a POSIX environment, it works. If you're on Windows, don't worry, there are two options. If you are able to install Cygwin, you use this, done. Or better yet, there's another shell called Baboon, which is a pre-configured Cygwin, Baboon, B-A-B-U-N. Baboon shell, you use it, it's a pre-configured version of Cygwin with Git and all the stuff, much better than plain Cygwin, and you're able to do it. Or, if you use PowerShell, there is another project called Push GVM, which is pretty much the PowerShell version of GVM, and it works. Anyway, you got GVM working already in your computer. The next thing you do is install Gradle. So you just do GVM install Gradle, boom, you're done. Do you need to install a different version? Okay, so first thing you do is GVM list Gradle. It lists you all the different versions of Gradle that you can have access to. And then you say GVM install Gradle, whatever version you need. And then you can switch from one version to another. GVM takes care of downloading the distribution from the right place and then configure your path environment so that it always points to the right version. You can even have two different shells with different Gradle versions working. That's pretty cool. So the project that we have that we're going to use is very simple. It's a very trivial Java application, and that has a build Gradle script and a POM file. So we will be able to build this app using either project. So I'm going to show Maven first, and I want you to concentrate on the blue areas. The blue areas are the ones that are very specific to the project, and the black areas are what we need to put else to just please the build tool. So here is Maven. A bunch of XML. So we put the coordinates, the group, the artifact ID, packaging, because we're talking about the Java project, the version. And just for giggles, there's a dependency on JUnit because we need to compile tests. Remember? Here we have a food test, so we relied on JUnit for that. All right? Remember the black to blue ratio. Let me show you the equivalent Gradle build for this. Less black than before, right? And we have the same information. Now you may be thinking, why do I have to apply the Java plugin? If I go back to Maven, well, there is no need to say something that this is a Java project. It is assumed. And this is one of the big changes that you see in Maven. Maven was designed to build Java projects only. Gradle is designed to build any kind of project that you want. Do you want Groovy? Just apply the Groovy project. Do you want a Scala? No problem. Apply the Scala plugin. You can apply, there's a JavaScript plugin too, so you can have a mix of Java sources and Groovy sources or Java. As a matter of fact, you can build C and C++ projects with Gradle. You can even build Objective-C plugins, projects with Gradle. This is the reason why we apply a language here, because Gradle itself is language agnostic. Even though it's built with Java and it's built to run inside the JVM, it can be used to build something else. So last year I was here with a customer that had a lot of code written in C and C++, and they were also doing a lot of stuff with Groovy and Java. They could switch to Gradle. Instead of using Make from one and Gradle for the other, they could put an homogeneous build tool for everything they have, because they were able to build C++ with this tool. Now, yes, the question is, I mentioned jar, the packaging here. Why I'm not mentioning jar here? Because again, the conventions. The convention here for the Java plugin is that most likely you want to build a jar of this project. So it's going to be there. If you need to build a var, then in Maven, you say packaging var, and then there has to be a var plugin also explicitly said, right? In Gradle, you say apply plugin var, nothing more, because you're following the convention. But if you do not, if you need to go away from the convention, then you can explicitly say, I want to package this as a jar, or as an ER, or some other kind of packaging. So I have the following scenarios for you. Some of them may be, yes, another question. Also, what is going on with Maven Publish? Okay, so because Gradle is agnostic to the language, right? It should be also agnostic how you want to deploy your project. So in this case, we're saying we want to deploy our project using the Maven conventions for a POM file. If there's nothing else that we need to specify besides the group, the version, and I'm waiting for another question here. What about the artifact ID? What about the project name? It's a good one. Here it is, right? The artifact ID sample. Where is the name of the project here? By convention, it's going to be the same directory that holds the project. If this name is not good enough, you can change it on the build file. Or there's another build file called settings.gradle where you can specify the root name of the project. But again, here the idea is your build file should define how your project deviates from the convention. So even though Maven here follows conventions, you still have to specify some things, right? Here, if we are just Java project, we are not telling where source main Java is because it is conventional. We're not telling it what's the name of the project because it's based on the directory. Another thing that should pop up to your mind is, what about that repository section? It could be JCenter, or it could be Maven Central, or it could be Maven Local. In the POM file, we don't specify repositories if we're consuming everything from two places. Maven Central or your Maven Local repository, right? You could also specify different servers if you put settings.xml. Well, in Gradle, because again, we're agnostic to the language or agnostic to the deployment, we're also agnostic from where the dependencies will come in. So I could say JCenter or Maven Local or Maven Central or any other Maven compatible repository. I prefer to use JCenter because it's a superset of Maven Central and has much more artifacts that Maven Central does not. Nexus, yes, you can consume from any Maven compatible repository such as Nexus or Artifactory or Archiva or whatever you need. Where do I configure? You configure here, right here on the build file. Yeah, the build file right now, we're showing just a tiny portion. Well, actually, this is the whole build file. But you can define external definitions for all repositories that may go in your Gradle home, like Maven home, or this will be global to yourself, or you put it on the build file, it will be local to the project. Now, the last thing is, what about the test scope here? We define it that this dependency JUnit is going to be on the test scope, which means it's going to be used to compile tests and to run the test. What do we use here in Gradle? We say something else. We say test compile, because we also have test runtime scope. If it's test runtime, means it's going to be used only for running the test. How do you specify in Maven that you need a dependency for running tests but not for compilation? You could use provided, but let me tell you, that is a hack. Because you're telling with provided that you need the dependency for building the project, but once you package the dependency is gone, you usually assume that the dependency is going to be provided by a container or is not used at all. So it's kind of hidden from the final deployment. Or you use test, because again, it's going to be used for test only, right? If you put it at runtime, certainly you can use it for testing, but it's also going to be used for your runtime deployment, and that would be a bad thing to do. In the case of Gradle, we can say test runtime, and we can be sure that it's going to be used only for test runtime and nothing more. You could probably use something like provided in Gradle, but it would be better if you use the test runtime in this particular use case. So now that we know this, I have these scenarios, and you probably have come across some of this. Let's first create an executable, launchable application. So we need to do something with the manifest, most likely. The next one is create an executable fat jar, which means put all the dependencies in a single jar and still have that jar being executed. And finally, have an installable application. So let's create a distribution that you can ship as a zip file maybe to your customers or to other teammates, and they can run the application, right? So first one, let's go with the executable launchable application. There are more things that you have to put on the POM to make this happen. What I'm showing is the minimal configuration. In this case, is apply the exec Maven plugin. Now, one of the things that I found when applying the exec plugin is that, well, you most likely, once you have checked out your project, you want to give it a try, right? So you go ahead and call Maven exec Java, and it fails. It tells you class not found exception. Well, that's weird. There's my source code. There's my tree. What's going on? It turns out the exec Java does not have a dependency on compilation, so you explicitly have to compile your code before you run it. This is a key thing when I'm going to show you the Gradle one. This is all that you need. If you follow the conventions, if you do not have any external dependencies, you don't have to define repositories. Just 3 lines of code, and that's it. The only thing that you do is you apply the application plugin, you define what is your main class, which you do here in Maven 2, and that's it. Okay, so let's jump into the code, because I see some smiley faces here. Let's see. I think I already have it somewhere here. No, that's not it. I think this is it. Oh, this is another application. Oh, silly me. Let's go here into my user home. Yes, I make it bigger. It's Gradle. There we go. There we go. Better? Okay, sorry. Woo. So let's see. This is the sample project that we were talking about. There is some configuration there. A great thing about Maven is that you can, yes, question? So the question is, how do you bootstrap a Gradle project? Easiest way is that if you already have a Maven project and you have the Gradle command available, you simply say Gradle init. This will generate a build.gradle file that parses your POM file and will define the group ID, the artifact ID, the version, and all the dependencies. Everything else, which is Maven specific, cannot be put into the Gradle file. So if you depend on a very specific Maven plugin, you have to locate the Gradle one and push it into your build file. But at least it gets you going. Or if you start afresh from zero, the easiest way is, and my favorite one, build.gradle, like that. It is very easy, I would say. But Maven has this thing called archetypes. And I have a few things about the archetypes in the case of Gradle. I'll come back to this question. Sorry, is it Gradle? Is it possible to use Gradle and AND? Yes, it is. The easiest way for you to use Gradle and AND is that if you go to your build file here and you already got a build file, a build.xml. I don't have a test use case for this, but if we do have network, we can do it live here because that's a really nice question. We go to gradle.org and now you can see the documentation here. Go into documentation user guide. There we go. And now we say AND using AND tasks. There we go. So what this thing is doing, there's always an AND variable, which is of type AND builder. It's a common class in every Groovy distribution that you can use to invoke any AND task that you want, as long as it's defined. But there is also a way for you to load the build XML file that is already there. And the crazy thing is, you can have a Gradle task depend on an AND task, which means the AND task is going to be called first, and then your Gradle task. Perfect integration. Sadly, not possible with Maven. You cannot call Maven goals inside Gradle. It will be completely like a black box. With AND, it's much better. Excellent question. Thank you. From Maven script, from the POM file, you can generate a build Gradle file. Yes, but doing Gradle in it. Sadly, no. What we recommend with Gradle is that you consume your build XML from Gradle and start calling your AND tasks as they are. And progressively, you migrate those AND tasks as Gradle tasks. So in this case, you don't have to throw away your AND build. You just put a nice groovy Gradle layer on top. And as time passes by, you migrate fully to Gradle. Whereas from AND to Maven, you can use AND run, but eventually you have to migrate almost in one step. And from Maven to Gradle, sadly, is almost also a single step. So what we have here, let's go back. This is the full example. And let me show you the code. It's very easy. The source main Java sample foo is a simple class. It only outputs hello world. And I believe there is a test. No, if it's failing or not. Yeah, it's a full test. Uses JUnit. Perfect. So this is our project. In the case of Maven, again, some coordinates. You define a property that's going to be used later. And here is the plugin, the exec plugin. In the case of Gradle, we only need to apply the application plugin, and that's it. So let's run this. Let's go into sample and do Maven clean. There we go. Then we do Maven exec Java, isn't it? And I expect a failure. It says class not found exception. So this is the reason why you have to compile it first and then run it. Yeah. So if you remember to do that, there's a hello world, then it works. Now let's do that in Gradle. Let's do a clean. So we start afresh, right? Now we say Gradle run. compiles the code, processes the resources, runs the classes, done. Let's do that again. See that the output of the project is itself is the same, but what happens with the tasks? It says that everything is up to date. Remember the inputs and the outputs? I didn't change the source code. So when I run it, I just run it. Now you notice that the runtime is less than a second now. I'm not running the Gradle daemon. If I were to be running the Gradle daemon, this will be much faster, perhaps half the time or even less. All right, so you may be wondering, so Andres knows Gradle, so of course he knows which tasks have to be run. How do we know which tasks can be run in Maven? Well, we can say Maven help, isn't it? And it tells us about the life cycles. If you have a specific plugin, then you can say Maven, the name of the plugin, maybe has a help. We don't know. In the case of Gradle, it seems simple as saying Gradle tasks. And it tells you everything that you can do. If there are some hidden tasks or some dependent tasks, you simply say -- all. And now you get more tasks, I guess. Yes. The start scripts, that was a hidden task. Process test resources, compile test Java. So now you see everything that you can invoke. And there is one more thing that I like about Gradle. Let's see something, another task, for example, process resources. Gradle clean. I want to invoke process resources. So I invoke process resources. But I could also say Gradle clean P capital R. And Gradle will try to expand this to match a task name. If I just need to define as many letters, or as few letters actually, as possible for a task to be unique. So I could do proc R like this, and it will still be found. So this is nice. Okay, so far so good? Let's create the this makes it executable. Now let's create the executable fat chart. Does anyone know how to do this with Maven? Well, turns out there is a plugin called the Shade plugin. The Shade plugin allows you to put all the dependencies in a single jar. And if you want, this is only putting things in a single jar. And if you want this to be executable, then you have to be sure to define a manifest entry. So this is what we're doing here. We configure the plugin, again look at the blue stuff. We also define a transformer so that the manifest entry is there. If this manifest entry is not defined, then you will not have an executable fat jar, only a fat jar. Now you see another thing at the bottom of the slides. How do you create this fat jar? Well, you run the package go, because the plugin is bound to this phase, to the package phase. But if you don't care about tests, you have to specify skip test equals true. Because every single time that you invoke the package lifecycle in Maven, it will try to run the test, no matter what. In the case of Gradle, we do this. The name of the plugin is called Shadow. It was originally based on shade, hence the name. There are several ways for you to define plugins. How do you consume plugins in Gradle? This is the most recent one. You define the ID. We'll show how to find those IDs and the versions. You apply the Java plugin, apply the application plugin, define the main class name, and nothing more. I'm applying the common slang dependency here just so we can show that the classes of this dependency are found in the fat jar. So in the case of Maven, there should be a dependency for common slang as well. All right? Let's see the POM file. The POM file has the Shade plugin with that thing. The reason why I was using a properties to define the man class name is because I use it here and I use it in this other place. And then we see the dependencies, common slang. All right? In the case of Gradle, we apply the plugin, the application plugin, main class name, our dependencies, nothing more. We're using the conventions. There's nothing else that we need to configure. Okay? Maven clean package -d skip tests. See, that tells me something, that you guys remember these. You use it very often. That tells me that running tests when they should not is something that shouldn't be happening, isn't it? There we go. So now we do a tree on target. And we got an original sample jar and our sample jar. So let's see what is inside. Unzip -L. Target original. That is just our project classes. And sample should have the shaded one. So there we see that it has common lengths, and we go all the way up. Too much. There it is. There are full classes. Pretty good. All right. Let's do that with Gradle. Gradle clean shadow jar. Notice how many tasks are going to be called. The tests were not called. Why? Because I didn't tell Gradle to run the tests. So they don't appear there. Compile my code. There is no jar task here. It's only the shadow jar. So by applying the Java plugin, I have access to the jar task. But this will be akin to the package goal in Maven. But it wasn't called because I didn't say I need it, and nobody else needs that jar. So let's look into the build directory. And we got one that says sample 00 snapshot all. This is our shadow jar. Oh, lips. Build is a conventional directory like the target for Maven, exactly. So this is our shadow jar. And now we can happily say java -jar, too much, build, libs, sample. Now it runs. It's a fat executable jar. Okay? Final scenario. How to make a distribution of this. So we're aiming to get a directory or a zip file that contains something like this. Some launchable scripts and all the jars that we need for our application. So for Maven, there are a few ways to do it. You can use the assembly plugin, which I guess most of you are familiar with. You need to define an external XML descriptor, which is the assembly descriptor, where you say, these are the files that I need. I want to copy from this to that. You put all the instructions. So you can do everything you want. You have to create the launchable scripts by yourself because the assembly plugin does not do this. Or you can configure the app assembler plugin, which generates the startup scripts and puts the libraries together. So in a combination of app assembler plus assembly, you can copy license files and readme and everything else and let the app assembler put the libraries and the launch scripts together. In the case of Gradle, this is again, why? Because the application plugin does everything for you. Okay, so let's do that. Maven app assembler assemble. Let's do a clean. Tree target. And there it is. For some reason, the sample jar is missing. I tried to configure these things exactly as you will find it from the net, so from the plain documentation, as is, and it's failing. Now, as another thing that we'll find is that, let's see, if we we comment out the shade plugin and run it again, let's see what happens. Still the same thing. Something is missing. That is because we need to call package directly. So see, these are the things that you need to know with Maven. The tests were run. I didn't ask for the tests. Still they were run. Finally, it's there. So I can run this saying target, what was the name? Assembler, bin foo. There we go. You see, we had to know that we had to call package. And notice that I commented out this. And it was a good thing that I did, because if I leave it out, then this jar here, is it going to be a plain jar or a fat jar? It's going to be a fat jar. And I already have all my dependencies here. That will be a problem. So with Maven, you start to have to use profiles in order to separate things. And I've been told from a very good source, if you start to use profiles, you're doing it wrong. Profiles are kind of like a hack for this thing. We shouldn't be using profiles as much as possible. Anyway, it's the only tool that we have. So I don't care if people refer this as a hack or not. This is the only way that we can make it happen with Maven. In Gradle, clean, dist, zip. Have a look at the different tasks that are going to be invoked. Classes, jar, start scripts, and this zip. Remember that this Gradle script can create a fat jar if I call shadow jar. That shadow jar was not called, so the jar that we find here, actually, where is it? It's inside distribution. So let's go inside build, distributions, and unzip this one. The jar that you find there is a plain jar. So let's run this. Sample bin foo, in this case a sample, and it runs. All right. I'm almost running out of time, but I need to show you multi-projects because this is really great. A multi-project build, I have it both in Maven and Gradle. In Maven, you define your modules. Each children has to have a POM file, dependencies. With dependency management, you can define all the dependencies that all your children project may have. Fine, right? In Gradle, you have a main root file where you can say, for example, the root is a base. This means it will have a clean task with nothing else. All the child projects will have Java and have this repository and have these dependencies. Then you go into the children, project 1 and project 2. The project 1 has a POM XML. It has to have one, but it doesn't have a build Gradle file. The thing is that if there's nothing that the child requires different from the root project, there's nothing else that needs to be defined. The second project has a POM file saying I depend on my sibling and I'm also executable. And the build Gradle file says I'm executable, so I have the application plugin, and I have a dependency on my sibling. Okay, let's go into project 2. And this is why I switched to Gradle. Do a Maven clean here. Remember that this has a dependency on project 1, and this is an executable project. I want to do this. Maven compile exec Java. I want to run project 2. I expect Maven to compile project 1 because it's a dependency, and compile project 2, and then run my project. Who says it's going to work because it's Maven? Who says it's not going to work? Can you tell me why? So it will be only for this project, what you're saying. It's only for the child project. Well, it actually is a project with dependencies. And that's the hack. We need to install the dependency on a repository that project 2 can reach, right? Usually that will be Maven local. So now we have to deal with the realm of snapshot dependencies. That is a problem. Because if I forget to install, I make a change in project 1 and I forget to do the install, I already have outdated artifacts, right? Let me show you Gradle. Remember that we are in the project 2. Let's go up. Let's do a clean here so that you know that everything is clean. Project 2, Gradle clean, no, Gradle run, right? We expect project 1 to be compiled, project 2 to be compiled, and then be executed. Isn't it? That's true. There was no need for a local repository. Exactly. Why? Because the classes, the resources, everything is already in project 1. We just need to reach it. Now, let's say we make a change in project 1. Let's change this to version 4. Project 2 did not change. Recompile. See what happens. Project 1 was recompiled. And now I got the right thing. Again, no install shenanigans. No snapshot problems. This is the reason why I believe Gradle is better. So I only have 1 more minute left. Yes?
So the dependencies you don't download, you do download, but there is no cache.
There is no, your dependencies, external dependencies get cached, and your local dependencies, in the case of a children project, the classes are already existing, so it uses directly the compiled classes. The cache is in the build file, in the field directory of the project 1. No. So there's like Maven, Gradle actually you can reuse the Maven cache and the Gradle cache. It has both. And so one more thing, the question about archetypes. Gradle does not have archetypes, but there is another project called Lazybones, which allows you to bootstrap any kind of project, even Maven ones. Lazybones can be used to create Gradle projects. It's as easy as installing using JVM. JVM install Lazybones. Then you do Lazybones list. Let's go into TMP. Lazybones list. List. This will tell you the different archetypes that you have access to. Then you do Lazybones create ASCII Dr. Gradle. This will be documentation. Doctor, that will be the board name. ASCII Dr. Gradle. This is hits. Okay. And if we look inside this directory, it already has a build Gradle file with everything that we need. So the template takes care of that. Okay, last thing. If you want to know which plugins are available, go to plugins.gradle.org. You can search all of them, and it tells you how to install it. And every plugin has a documentation on how to use them. There are many plugins that you can use. The slides will be available for you. These are the ones that I consider the most useful. So don't worry about that. And thank you very much. I ran out of time. I will still be around at the conference. If you have any more questions about Gradle, I'll be at the other side of the building. So thank you again very much.